Hello. In this video, we are about to cover the topic of BFS and DFS, and we can know about the BFS and DFS time complexity as well as space complexity. So, time is equivalent to the number of nodes which has been traversed. That means T of n equals O to the power of n power of d. This is the time complexity of BFS, and of DFS it's O to the power of order of n into d, where d is the depth of the search tree. That means number of levels of the search tree, and n is the branching factor, that is maximum branching factor. Among all the branching factor of each node, we have to consider a branching factor. So once again, the time complexity of BFS is order of n to the power of d, and time complexity of DFS is order of n to the power n into d. So where d is depth of the search tree and n is branching factor. So let me show you the demonstration. So consider this graph. This is a structured graph, and it has its own hierarchy and leaf nodes and initial node. These are the terminal nodes, that is called as leaf node. So if you want to do in BFS, then you have to first consider a starting node. That here the starting node is A. Then from A, how many branches, how many nodes have been created, as A is the parent. A is the parent of B and C. This B and C is parent to the another nodes. So as being the parent node, A has to be first put in the stack, and according to A, B and C are forming. So you have to put B and C. Then you have to ignore this because A doesn't have another node. Hence, considering the B has D and E. So you are considering D and E. So after this D and E, no other node is there for B. So you are coming out of B. Then the next node is C. So C is the parent for F and G. You have to write F and G. You have to insert F and G into the stack, and the C hasn't C does not have any other nodes, so C should come out of the stack. So after considering the next node is D. So D has only one node, that is H is the child node to D. Then D doesn't has any other node, so you have to cancel the D. Then E is there, same as E and J, I and J is there, I and J. So E hasn't any another node, so F has K. So you will write K here. You will come out of F, and you will consider G. So G doesn't has, you will cancel. H doesn't has, cancel. As H, I, J, K are all the leaf nodes, it doesn't has any other child nodes, so it will directly come out of the stack. This process is called as BFS. BFS is nothing but taking the branches into consideration, and putting it into the stack. And after putting it in the stack, you have to consider that node itself and check whether it has a child node or not. Then you have to insert into the stack, and in order you have to remove the stack according to the child nodes. So the time complexity is O to the order of n to the power of d, because here 2 is there. It means 0, 1, 2. This is the branch. So 2 to the power of 3. Here 3 hierarchy is there. So 2 to the power of 3 equals 8. So in DFS, first you will consider it is like a depth search. You will go till the depth and then backtrack it. So first node you will consider A, then again you will consider B, then from B you will consider C. C, no, this is BFS. So according to DFS, first you will consider A and to B, then to D, then to H. Then H doesn't has any child node to go further, so it will backtrack to D and B. Again B has another neighboring child node as E. So you will go to E, then you will go to I. I doesn't has anything, then again you will backtrack it and it will come to J. Then J doesn't has any other child node, then you will backtrack to E, then to B, then wapas to A. Then from A, another child neighbor is there. You will consider C. Then again you will go through deep as a hierarchy form. F is there. From F, K is there. Then K doesn't has any other child nodes. So you will backtrack to F, backtrack to C. Then C has another child, G. So same as order. A, B, D, H. Then backtrack to E, I, and then J, then C. You consider this C, F, K, G. So this is DFS, and so in BFS it requires a lot of memory space and time consuming if the goal state is at the bottom end. So it requires a lot of memory space if the goal state is at the bottom end. So it uses a first in first out queue mechanism to implement it. So time complexity, as you know, b to the power of d. It's an optimal. Yes, it is an optimal. So if you consider DFS, it occupies a lot of memory space and time extends when the solution is at the bottom end of the tree and is implemented using LIFO stack. So here compute is no time complexity b to the power of b to the power of m. Space is b of m and optimal. Yes, it is an optimal. So this is DFS. Thank you.